Okay, guys, we are in next math notes 8.3.2. We're looking at polynomial theorems. We're going to look at two theorems here, the remainder theorem, three theorems. Remainder theorem, factor theorem, and rational zeros theorem. They're all related. We'll go through them. I'll give you an example at the end or a little problem at the end to work on here. So, the remainder theorem, it says for any number c, when a polynomial p is divided by x minus c, that would make c a root. The remainder is the value of p of c. So this lets you know that if you were to divide by x minus c, whatever you got for p of c would be the remainder. For example, if the polynomial p of x equals x to the fourth minus x cubed plus 20x minus 48 is divided by x minus 5, the remainder is 552, and we know that because 5 to the fourth minus 5 to the third plus 20 times 5 minus 48 equals 552. Okay? Which means really that 5 is not a root. All right, so 5 is not a root because we have a remainder here, and we know that our roots will all have remainders of 0. We could test this out real fast. If I started with a polynomial in factored form, which will let me know right away that my roots are going to be -2 and +4, and I multiply this out, then I get x squared minus 2x minus 8 is equal to p of x in standard form. And so I could show that those roots give you a remainder of 0 by plugging in one of those roots that I know. So I could say p of -2 is equal to -2 squared minus 2 times -2 minus 8. And that would give me +4 plus 4 minus 8, and that would equal 0. And if it has a remainder of 0, then it must be a root. And in fact, that's what our next theorem is. It's the factor theorem. Follows from the remainder theorem and states that if a polynomial has a root of x equal to c, then p of c equals 0, and x minus c is a factor of p, which is a fancy way of saying that if you get a remainder of 0, then the number you plugged in is a root for the polynomial function. For example, given p of x is equal to x cubed minus 3x squared plus 4, p of -1 equals 0. Therefore, x plus 1 is a factor of p of x. We could then use that to find the other factors of that polynomial, which is where we're headed with this. If we divided that out. Okay? Which we'll be doing in the next set of notes. Rational zeros theorem. This may, the first two theorems may lead you to question, well, that's great, Mr. Jewell, but how do we figure out if, what number to start choosing? If we're trying to find the roots, we know that if we plug in that number and we get a remainder of 0, then it must be a root. But how do I know what number to start with? What's a good sort of starting point with my guess? Well, that's what this theorem tells you, the rational zeros theorem. It says that if the polynomial has integer coefficients, then every rational zero of p is in the form of p over q, where p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. So another way to say that is if you take the last integer over the first coefficient, and you take the factors of both of those, you'll find all of your potential roots. So they give you an example here of 2 times x cubed plus x squared minus 7x plus 6. I know that my potential roots then have to be factors of 6 over 2, because this is my last over my first. So factors of 6 include 1, 2, 3, and 6. Factors of 2 include 2 and 1. So I'm going to take all of these and put them over 1. And then I'm going to take all of them and put them over 2. And those are my potential factors, my potential roots rather, for that polynomial. And so that's what I should start testing. You'll notice that a couple of these reduce, right? 6 over 2 would be 3. That's 6, 3, 1. So there are some duplicates in here that make this a little less daunting than it looks right away. And so you need to start plugging those in and see where you get remainders of zeros, and those will give you your roots. So I'm going to leave you with one to think about here. I'm going to give you a cubic function. I'm going to say p of x equals x cubed plus 2x squared minus 5x minus 6. I want you to see if you can find the roots for that polynomial. So start with your last over your first and plug in those numbers until you find things that have remainders of 0 that would give you your roots, and then you can write it in factored form after you do that. So find the roots and write the polynomial in factored form.